Okay, in this video we are going to continue problem set number 7 from my Calc CD class. We are going to be doing a triple integral over a region in space, dv, and it's not going to be a box, so it's going to be some region that's going to be defined somehow. Let's take a look. So this is number 9, f of x, y, z is x plus y. Remember, you don't have to worry about that. What you have to worry about is the bounds. So in this particular case, we have x going from 0 to 1. So those are constants. That'll go last. That'll be the final integral. Y is going from 0 to x. So y depends on x. Y definitely needs to go before x when you integrate, but it doesn't really matter what its relationship is to z. On the other hand, z is dependent upon y and x, which means that z definitely has to go first, right? So now that I've looked at all of them, I know that z has to go first because it depends on y and x. So that'll be first. Y has to go next because it depends on x, and then x will be the last one that we do because it's constant, right? You will always want your outer integral to just be the constants. The other ones, it depends on what depends on what. I think that sentence made sense, but maybe not. All right, let's write this down. So we have the integral from 0 to 1, 0 to x, y to x, x plus y, dz, dy, dx. All right, so we'll be that point we'll have 0 to 1, 0 to x. Integrate this thing with respect to z. I'm gonna make it the quantity x plus y and then times z. Now z is going from y to z equals x. So I definitely want to put z equals there because all three variables are in play and I get confused. And then we'll still have dy dx. Okay, so we still have our double integral, 0 to 1 and 0 to x. You let z equal x and z equal y will just give us the quantity x minus y. And we need to integrate this with respect to y and then with respect to x and do the whole thing. So integrating this, I think what I'm going to do is expand this first, right? Because that's just a difference of squares. So before we actually do anything, I'm going to say 0 to 1, 0 to x, x squared minus y squared, and then dy dx. Integrating this with respect to y, just treat that x squared as a constant. So we will get the integral from 0 to 1. You're going to have x squared y minus 1/3 y cubed. And y is equal to 0 to y is equal to x. So first we replace y with x. Then when you replace y with 0, everything zeroes out. So really you just have to replace y with x. In terms of writing, I mean, you're doing x and 0, but you know. So we'll get x squared times x is x cubed, and then minus 1/3 x cubed. You can definitely simplify that, and you should, to the integral from 0 to 1 of 2/3 x cubed, plus 1 times the reciprocal is going to give you 2/12, which is 1/6 x to the 4th from 0 to 1. When you plug in 1, you get 1/6. When you plug in 0, you get 0. That's our final answer. Let's take a look at the next one. All right, we got f of x, y, z is x, y, z. X goes from 0 to 1, so that could go last. Y goes from 0 to the square root of 1 minus x squared. So y definitely needs to go before x. Maybe when you look at z, it might have to go before y, or it could have to go, well, no. Not in this case, because we already know that y only depends on x. If y depended on z, y would have to go first, because it depends on z and x, but not the case here. Z goes from 0 to 1. That can happen at any time. So we definitely know that y has to go before x. Z can go at any time. Let's write this down. Also, it's of note that f of x, y, z is x times y times z. That's a product, so we can use that property if one of the integrals doesn't depend on the others, and that actually is the case. Let's write it down first. So this has to go before x. So I'm going to go 0 to 1, 0 to the square root of 1 minus x squared, 0 to 1. X, y, z, I'm going to go dz, that's my inner integral, but z doesn't depend on x or y, so I can actually pull that out as its own separate integral and just evaluate that, and then dy dx. So let's do that. I'm just rewriting here. I'm not actually evaluating anything. So we'll go 0 to 1 of z, dz, and then 0 to 1, 0 to the square root of 1 minus x squared, xy, dy dx. I tend to think of that double integral as like the standard double integral where you end up with dy dx. I don't know. I think most of them are kind of like that. All right, so integrate z. You get 1/2 z squared from 0 to 1, which is just 1/2. And then here we're going to have the integral from 0 to 1 we integrate with respect to y. So we get x 1/2 y squared from y equals 0 to y equals the square root of 1 minus x squared dx. So this is actually better than it seems because y is squared and we have y as a radical. So when you square a radical, you just kind of get rid of the radical. From the integral with respect to z, we just are getting a 1/2. So 1/2 there. There's another 1/2 that you can like pull out of this integral. So I'm going to take that out. And then we're going 0 to 1, x. When you plug in the square root thing, you just get the quantity 1 minus x squared. When you plug in 0, you get 0. And then dx. So at this point, it's 1/4. I'm going to distribute, which I think is what everyone would do. And now we're just reversing the power rule, and we just have to be a little careful. So it'll be 1/4. Then we have 1/2 x squared minus 1/4 x to the 4th, going from 0 to 1. When you plug in 0, everything zeroes out. So you just get 1/4, the quantity 1/2 minus 1/4, which is 1/4 times 1/4, which is 1/16. All right, we got one more problem to do, and it's kind of annoying. So let's look at it. We have f of x, y, z is e to the z, and we're doing the triple integral over the region shown, which is like a tetrahedron, like a four-sided thing. I mean, I guess it's a pyramid, but it kind of doesn't feel like a pyramid because it, I don't know, has that right angle that occurs at the origin, I guess, is why I don't feel like it's a pyramid, even though that is definitely a pyramid. So how are we going to do this? Well, first I'm going to do this, I'm going to go dz, dy, dx, because in my mind that makes the most sense. I'm going to start off by going kind of like from the floor, which is the xy plane, to the tilted plane, which I'm going to have to find the equation of. So we're going like this. So that'll be from the xy plane to the tilted plane. I need to find the equation of the tilted plane, which is like the vast majority of the work, assuming you're just going to use a calculator to get the answer, which is what I'm definitely going to do. So, all right, so let's list out what we got. So the xy plane is 0, and now do the work for the tilted plane. We got 3 points that we definitely know, 4, 0, 0, 0, 4, 0, 0, 0, 6. I'm going to make 2 vectors out of those 3 points. So v1, we're going from here to here. So it's going to be 0 minus, so negative 4, 0, and 6, right? Do terminal minus initial. v2, I'm going to go from the first to the second, right? So that's going to be 0 minus 4, 4 minus 0, and 0. Now I'm going to find the cross product of these. I'm not going to show the work. Our cross product ends up I times negative 24 minus j times 24 plus k times negative 16, which means our plane using the point 4, 0, 0 and point normal form will be negative 24, x minus 4, minus 24, y minus 0, minus 16, z minus 0 equals 0. So there's a bunch of stuff you might need to review there about finding equations of planes. I found 2 vectors, I found the cross product, and then I used point normal form to get the equation, which is like my preference for how to get the equation. I am going to just expand this thing a little bit. So first I'm going to divide everything I see by negative 8, and then kind of collect, I'm just dividing everything I see by negative 8. So I get 3 quantity x minus 4 plus 3y plus 2z. This is the equation of the tilted plane, so I'm going to take this and just fill it in up top, but I'm going to solve for z, right? Because those are the z bounds. So z is negative 3/2 quantity x minus 4 minus 3/2 y, and that's it. So that's what z is doing. Now we need to figure out what x and y are doing. So what I'm going to do is I'm going to take that picture that I have and redraw it as just a 2-dimensional picture, which looks like this. So I want to go dz, dy, dx, right? So x should be the constant bound, so x is going to go from 0 to 4. And then y has to go from bottom to top, which is from 0 to 4 minus x. All right, so z goes first, then y, then x. This is what our triple integral will look like. And then, as I mentioned, I'm just going to use a calculator to evaluate this. You can do this by hand. It's not terrible. It's not great. It's pretty terrible. I don't know. So this, I just punched it in. Definitely not terrible if you use a calculator. So I got 4/9 the quantity e to the 6 minus 25. Enormous volume. You get a lot of really big volumes when you do these problems. Okay, that's the entire problem set. I hope this was helpful, and good luck.